related rates problem and thought, why is this circle all of a sudden shrinking? Or in the next example, why is this ladder falling down? Like first it was here, now the top of this ladder is here. Well, some people think that calculus is all of a sudden a physics problem, but here's the secret. Related rates is nothing new. As long as a person knows about implicit differentiation, he can apply the same logic and solve related rates problem. The only difference is that it is simply implicit differentiation but with time. What did I mean when I said all of this? Let's see with a quick small debrief about what was that we are talking about right now. So we all know in implicit differentiation, whenever we have a y, we differentiate with respect to y and say dy over dx. You see a y, you differentiate and put dy over dx. Similarly, in related rates, you do the same with the variables, but instead of x, everything is depending on time because of the word rate. The word rate is how fast the thing is going, and anything that is fast is just depending on the time. So if I say that dr, or you see a radius, then when you differentiate this in related rates, you'll just simply say it's going to be dr over dt, or change in radius with change in time. Similarly, you can have dA over dt, which is area is rate area, and you can just say change in area with respect to time. And over here, if you see v could be volume, velocity, or anything. You can just say it's gonna be change in volume with respect to time. One thing to notice, in related rates, everything, every area, volume, radius, everything is differentiated with respect to time. That's one thing which is involved in related rates. Now, the real question comes, how do we solve these huge word problems? Because at a first glance, you look at it and you're like, wait, am I doing something else? But in reality, you are just doing what you have learned before and applying it in a real life scenario using some visualizations. First, you ask yourself, what is given? What does the question shares with me? What data do I have? And after that, you write what you need. Maybe you need to find the change in area, you need to find the change in radius, or you need to find the change in volume, or whatever it's gonna tell you. So you always find out, write down what you need. After that, there must be a thing combining the data and what you need with an equation. So let's just say if you're given a radius and it's talking about the square, you can always connect the area with the radius by using the formula for area. And you can say the formula of a circle, area of a circle is pi r squared. So in this way, you can say A is equals to pi r squared. And boom, you have connected your r and A together. So find an equation afterwards. After that, differentiate every variable with respect to time, be it a, be it r. When they're going to get differentiated, it's going to be dA over dr and dr over dt. This is the main step. Just like we did in implicit differentiation, wherever there was y, we add dy over dx. Over here, whenever there's a variable, you write d variable over dt. And after that, you plug in your differentiating variable or something, which usually we'll see in a question, this number 5, because a lot of students get confused. So I highlighted and we're gonna see it in action while solving questions. So let's just solve this question. First of the question is an expanding circle problem, which is a really common question which you can get, and it's one of the easiest ones too. So the question goes like, the radius of a circle is increasing at 3 centimeters per second. Find how fast the area is when the radius is 5 centimeters. Now, point to be noted, we follow those 4 steps. First, we write down what do we know, saying the radius increases at the rate of 3 centimeters per second. So d r over dt, change in radius, is the same as 3 centimeters. Now, right now, we know the area is expanding. The circle is getting bigger. So we know this rate is positive. Sometimes you can get a question which is of a shrinking circle, or which the rate is decreasing. Like first you were really fast and now you're really slow. So in those cases, there's nothing new. You just add a minus sign before the rate. But right now, this is about an expanding circle, so we put a plus sign. Now, what else? It's saying find out the area which is also increasing when the radius is 5. So we are mentioned about the radius. Now, we know we need to find the change in area, or how fast is area going. So dA over dt is our looking point. Now we have area, we have radius, and we have a circle with radius r. So how do we connect this equation? We say area of a circle, as mentioned before, is pi r square. Now you differentiate this. You say dA over dt, and obviously there's a 1, so the area of a variable is just 1 at the end. And similarly, pi r square, pi stays pi, r square becomes 2r, and then you add dr over dt because you differentiated radius with respect to time. Now if we further expand, we get dA over dt equals 2 pi r dr over dt. Now in this question, if we look closely, we know what does this dr over dt stands for, which is simply 3 centimeters per second. So you write dA over dt is equal to 2 pi. Now at what radius are we looking for? We're looking for at radius 5, when the circle is exactly 5. What's my area speed, or the changing area? So you say it's going to be 2 pi 5 from the question, and dr over dt is 3. And then you go further, you say 5 times 3 is 15, 15 times 2 is 30, and in the end, when you just solve this, you get 30 pi. And you can solve this pi if you want, but you can leave it like this. So it's 30 pi. Mind it, a lot of the teachers, they also give you a space for units. So when you need to write the units, it means the marks of the units are also included. So area is simply centimeter square, and time is just simply seconds. So centimeter square per second. The rate of units is important because they also carry significant marks in solving a question. Another kind of questions we see is a ladder problem, in which there's a ladder which all of a sudden starts falling, so the bottom moves away while the top comes down. And this might look like a physics problem, but trust me, it's just a simple math problem. Let's just see what's going on in this ladder. First of all, we have a wall, we know this, and then we have a ladder. Oh my god, my ladder is pathetic. Let me redraw these things. So let's just say this is the wall, and let's just say this was the ladder. Now a 10-meter ladder, so we know that the length of this ladder is just simply 10 meters. And now a 10-meter ladder is leaned against the wall, just like in my picture. Now the bottom slides away from the wall at 2 meters per second. Now hear me out. What is the bottom? What is the top? We know that this side is the bottom side, or the floor. The top side of the ladder is the upward section, which is leaned against the wall. Now they're saying this bottom moves away. With what speed? With 2 meters per second. And similarly, if the bottom is moving away, the top is also coming down. What speed? We don't know right now. Now for this example, let's just say this the bottom which we are referring to as bottom is just simply the distance on the floor, right? So we can say that the distance could be, let's just say x. X is my distance from the wall. Meanwhile, this top we are referring to is just simply the height of the thing. And if we just call this height, we can say as y. So we can say y is the height on the wall. Oh my god. Yeah, height on the wall. Now, with these things clear, we know we have x, we know y. And now we know 10 meters per second. So what else do we have given? We know that the change in x, or the horizontal distance, dx over dt, is 2 meters per second. Again, this is really important. And now they're asking, how fast is the top sliding down when the bottom is 6 meters away from the wall? So we also know that we need to find out exact when x is 6 meters away. So we know this. Now, in order to solve this kind of question, we need to engage something which includes x and y. Now, if we look at the diagram closely, we see a wall always creates a 90-degree angle. And now, after that, we see a 90-degree right-angle triangle. So you just say, we can use Pythagoras theorem here. We say x squared plus y squared equals the hypotenuse, which is 10 squared. Make sense? Further expanded is going to be x squared plus y squared equals 100. Now, your ideology is still the same. You find the equation, the next step is to differentiate this. Now x squared becomes 2x, but again, x is a variable, so you differentiate it dx with respect to time over dt. Similarly, y squared is going to be 2y, but again, y is a variable, so it's going to be dy over dt. And hundredths is just simply a constant, so it's going to be 0. And now, once you're done with this, you start to notice one thing. You see that the x is 6, my dx over dt is 2, and my dy over dt is kind of missing. So how do we find this dy over dt? We're going to use this equation. So, in other words, it's asking the top is sliding down when the bottom is at 6 meters. So, in other words, this is our thing. How fast is the top sliding? What is the top? Top is y. So we need to find dy over dt. And that's it. Now you have solved the puzzle. It's all replacing the thing. First of all, somebody asks you where's your dx over dt? You say it's already mentioned in the question. It's 2 meters per second. It's because the bottom is sliding 2 meters away. Now, you start to notice, then it's going to be 2. Do we have x? Yes, we have x. It's going to be 6. Do we have dx over dt? Yes, we have 2. Plus 2. Now, what about y? The real question comes, where is y? Well, in order to find y, we can apply the simple concept again. We can say x squared plus y squared is 100. And now, if my x is at that specific point, x is at 6, what would my y be? Let's check. It's going to be 6 squared becomes 36 plus y squared equals 100. You further solve it, you get y squared is equals to 64, and if we take a square root on both the sides, we say y is plus minus 8. But since we are talking about length here, we reject the negative side, we say y is 8. So now we need to know, we know that y is 8, my x is 6, I plugged in my x, I plugged in my dx over dt. Now I'm just simply going to plug in my y, it's going to be 8, and dy dt is the thing that I'm trying to figure out. Now you can just all expand it together. 2 times 2 becomes 4. 4 times 6 becomes 24, if I'm not wrong. So 24 plus 2 to the 16. dy over dt. Make dy dt the subject. It's going to be 16. dy over dt equals minus 24. Now if you further simplify, you divide 16 on both the sides. And then you get dy over dt equals to be minus 24, you simplify it probably with the table of 3. So it's going to be minus 3 divided by 2. And again, y is just a distance, so it's going to be meters per second. This is your sign. Now, a really good influence that somebody can infer from this problem is, why do we have a negative rate? Well, because if we closely look at the problem, the bottom, the right distance, the bottom gets bigger. Like you see, it's moving away. So this length, this whole red length would be bigger with time. And similarly, the top is falling down. So this thing would eventually get shorter, the purple side. That's why we have a decreasing rate or a negative rate. So that's why the negative sign is important. Whenever you're doing relative rates, if the thing is decreasing, going down, or it's like shrinking in size, then you always put a negative sign with its rate. Just like in this question. That's why we got a negative answer. So examiner may ask you like, why is the answer or why is the rate negative? You can say because it's negative because sign is important in relative rates, and negative means moving down. It means the top of the ladder is moving down. And I can make a lot of questions like these because relative rates is just simply applying the implicit differentiation in real life scenarios. So you just need to be careful about a few things. Never plug in the thing too early. Always differentiate first, then plug in. Also, again, I'm going to mention we are not differentiating with respect to x. We're differentiating with respect to time. So keep in mind, and once you start following this becomes easy. Because none of these questions are random. They're just connected with variables and equations, and once you start to see the pattern, it gets easier for you. My only suggestion, if somebody's working on these kind of questions and find it hard, you just solve many problems and apply this 5-step logic, and you'll be good. Because it's nothing, it's just two variables, one equation, you differentiate, and then you're differentiating with respect to time, and then plug it in, plug the things trying to find out. Don't go so deep in this, it's pretty simple. And with that note, this would be the end of the video. If you liked it, please share it among your friends, they also might need help. And see you in the next one.